So our next topic is, we are going to learn about different type of reactions in the organic chemistry. Okay, basically related to hydrocarbons. Let's first discuss it related to hydrocarbons. One, the very first one is known as substitution. Now substitution means you have to replace one atom with another one. Okay, with another. Then there is another one which is known as addition. Addition means adding without replacement. Okay, you are not adding something, but oh sorry, replacing something, but only adding. Third one, the very common reaction of hydrocarbon is combustion. Combustion means the reaction with oxygen. Okay, so these are the common reactions of the hydrocarbons, all alkanes, alkenes, and alkynes with oxygen. Okay, let's first discuss it with respect to alkanes only. Okay, just give me a minute, I'm just changing pen. Let's talk about substitution. Now, as these are saturated hydrocarbons, so they have single bonds and there is no, you can say, space for any other atom to get entered. So if we have a methane, I'm starting from a simple one. Methane mean all bonds are single, but I have to add bromine. It can't be added unless some of the hydrogen got removed. So one of the hydrogen, let's say this one hydrogen is replaced by bromine. Okay, and this one hydrogen which is removed is going to make bond with another bromine which is present over here. I'll just write the structural form. Just wait a minute, give me 1 minute. Hydrogen, hydrogen plus bromine and bromine. Okay, okay. Do you have a concept of electronegativity? No. Okay. um, Electronegativity is one of the concept in chemistry in which we say one atom is strong enough to attract the shared pair of electron. So halogens, because they have a higher nuclear charge, they have more number of electrons, they have a higher nuclear charge, they attract the shared pair of electron really easily as compared to any other ones. So hydrogen, being smaller in size and has a lesser nuclear charge, is less stronger as compared to bromine. So bromine can easily replace this hydrogen, any one of the hydrogen. Okay, you can replace this one as well, you can replace this one as well. Okay, so this bond which is broken is then replaced by hydrogen over here. So they are changing their place. This is known as substitution. Okay, now how do we name a compound? So this is methane that we know, and this is bromine. How do we name the haloalkanes? Okay, haloalkanes mean the halogen plus alkane. Okay, group 7 is known as halogens. The elements of group 7 are known as halogens. Okay, so if group 7 element is present, then how do we name it? We can name it simply. We'll write the name of halogen and then alkane. So the name is bromine, we would call it bromo. If it's chlorine, we would call it chloro. If it's fluorine, we would call it fluoro. If it's iodine, we would call it iodo. Okay, so it would be bromo methane. Okay, and this HBr would be known as, would be called hydrogen bromide. Let's discuss one more. Now there are three carbons. I hope you know the names now, like if depending on the number of carbons. Plus chlorine. Okay, what would be product? Good. Chloropropane. And and okay, this chlorine, hydrogen chloride. So it would be chloropropane and hydrogen chloride. Okay, let's move to the next part, which is the addition reaction. Okay, let's move to addition. Okay, addition reaction is a property of these unsaturated hydrocarbons, like the alkenes and alkynes. Okay, let's say we have a double bond here, H, 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 oh, sorry, I have to make two hydrogens only. Okay, now we have a space over here. Because of this double bond, we have a space over here to add something. Let's add fluorine. I'm not adding bromine because it has, I need to tell you something about it. Okay, we'll add fluorine because it has space. Because it has space. Okay, shall I tell you the detail, like what is meant by space? Okay, so we say one electron is shared here and one electron is shared here. Okay, so I've told you that halogens are electronegative. They have a power to attract the shared pair of electron, right? So one of the fluorine, one electron, though it has 7, it needs only one. It needs only one more electron to complete its shell. So this fluorine will move over here and this fluorine will move over here. So it would become C. I'm just representing bond to explain it. Otherwise there's no need. C, H, H and fluorine. Okay? It would break the double bond and convert them into a single bond. Okay? Got it. Great. So there are two fluorine now. So it would be known as difluoroethane. Okay. Good. So there is one identification reaction. It's a identification reaction for alkenes. And in this reaction, you put bromine into the alkene. So bromine has a brown color. So when you add bromine to the alkene, definitely is going to convert into a single bond. It's going to break. Bromine is going to break. So the brown color would disappear. So this is identification. If the brown color disappear, it would be alkene. Otherwise, it won't be. So it would be like this, double bond, H here, and here. So if you add bromine, the bonds would break which are present over here and here. These bonds are going to break and there will be formation of new bonds. Though there's no need to make bonds, I'm just making it to make you understand that this happens actually. Okay, so the name would be dibromoethane. Clear? Okay, the last reaction is the combustion one. Combustion one means to burn in oxygen. All hydrocarbons, whether alkane, alkene, or alkynes, they react with oxygen and produce carbon dioxide plus water. Okay? All. Then we have to balance it, that is a separate story. But all hydrocarbons react with oxygen to make carbon dioxide and water. Product would always be same. Clear? Okay. Um, there are two type of combustion. One is known as complete combustion and the other type is known as incomplete combustion. Okay. In complete combustion, oxygen is available in excess and it will result in the production of carbon dioxide. But in incomplete combustion, oxygen is not available or lesser oxygen is available. Lesser oxygen is available due to which carbon monoxide is produced. Okay, so if it's given, write the incomplete combustion products, then you have to write carbon monoxide instead of carbon dioxide. But if it's a complete combustion, it would be carbon dioxide plus water. Otherwise, it will be carbon monoxide plus water. Okay? Let's have an example. CH4 plus O2. It gives you, now this is excess, let's say. CO2 plus H2O. Okay. Have we learned balancing? Okay, let's balance it. Carbon is already balanced. Let's look at oxygen and hydrogen. Okay, so what shall we do? Okay, now there are four oxygen, two here and two here. So a total of four oxygen. So we put a two here as well. Okay, okay. This is now complete combustion. If it's an incomplete combustion, limited, let's say we have limited oxygen. So it would result in the formation of carbon monoxide plus H2O. Now, how would you explain it? Okay, whenever there is incomplete combustion, we write a fraction with O2. It's a rule. We write some type of fraction. It will be definite. I'll let you know what this would be. Okay, there are four hydrogen. Let's place two over here. Now, how many oxygen are there? Three. So it would be 3 over 2. If there are 5 oxygen, we would write 5 over 2. Why over 2? Because this is O2. So we have to divide it with 2. Okay? The number divided with 2 to get a 3 number. Okay. It would be simplified now. Look over here. Into 2. So simplified as 3. Got it? Okay. Let's move to the question which we skipped. There was one question, E part, which we skipped earlier. Why is not moving? The question was, why does F not decolorize bromine water? So F is a saturated compound. So it cannot decolorize bromine water. It won't show reaction. Simple. So no change would occur. Okay. we are done with the reaction of alkanes. Okay. Um, have you ever heard of chain reaction? No. Okay. Chain reaction is the one which once start is difficult to stop. It would keep on reacting again and again. Okay. Do you know the cause of ozone depletion? No. What is ozone? What is ozone in our atmosphere? Okay, good. So the ozone is depleting. What is the leading cause of ozone depletion in our environment? No. Carbon dioxide is a major cause of greenhouse effect or global warming. The ozone depletion is due to chlorofluorocarbons. Okay, we had a question. Okay, we did a question over here that it is present in, look, old refrigerators may contain a substance that can harm the ozone layer, right? So basically, this one is the chlorofluorocarbon that destroys the ozone layer. Though it is present in aerosols, the old refrigerators, the air conditioners, these produces chlorofluorocarbons. Now chlorofluorocarbons, because these are haloalkanes, the reaction once started with ozone is not going to stop. It's keep on decomposing ozone by reacting with it. So ozone is O3. I'm just telling this for general knowledge. Okay, when haloalkanes react with these haloalkanes, it converts into O2. Okay, so as ozone is converting into O2, we call this ozone depletion. That ozone layer is changed to O2. There, it's not ozone. It's no longer ozone. Okay, so one of the leading cause of this is chlorofluorocarbons, or you can say the haloalkanes. So haloalkanes may show the chain reactions, which once started are difficult to stop. Okay, one very famous reaction is with chlorine. It won't stop unless all the hydrogens are replaced. Here we have replaced only one hydrogen, right? Here we have replaced only one hydrogen. So this reaction keeps on happening. Oh, sorry, here. This reaction would keep on happening unless all the hydrogens are going to be replaced. Okay? And this is basically the chain reaction.